Well, this will be a code walkthrough for the Cambridge University Bacon Pi Raspberry Pi tutorials. I'm just gonna be stepping through the code, explaining it to you how I understand it, which hopefully will be correctly. But anyways, it's split into two files. We have the main right here and a GPIO file, which I'll go through after this. So, starting off, these don't really do anything as far as the Raspberry Pi is concerned. It's just for the assembler. It's just going to tell it how to organize the code. This being the initialization section. And right here is the other section, the text section, which we know starts at the memory location 8000. If I believe I'm pronouncing that correctly, because this is a hex number. So that's actually this next line right here. We're setting the stack pointer, which is just a special register in ARM assembly that just will update as things are popped and pushed from the stack to the top value. So this next section, I'm just gonna kind of go through it in blocks. I find it's easier to understand that way. I'll go through the four main ones that follow first. This serves to just it runs before the loop, and it serves to just enable output to our OK LED, which is pin number 16, and the turning it on is function number 1 for it. Next section right here, all it does is turn the LED on. This serves nothing but to create a time delay. This will turn the LED off. It's very similar to this, you'll notice. And this right here creates another time delay. It's just the exact same code right here. Alright, so we'll go through it in a little bit more detail. Um, Here we go. These right here, they're just aliases. Makes the code a little bit easier to use. They're just saying, from now on, anytime I use the name pin number, just know I'm talking about R0. And pin val, which will be the on or off, will be anytime I'm talking about that, I'm really just talking about R1. So, and then this is will initial or set the registers to 16, which is the pin number for the ACT LED that we're trying to turn on, and 0, which will turn the pin off, but kind of counterintuitively, all the pin numbers on the Raspberry Pi, all the pins on the Raspberry Pi are set to be on by default. So they're in their on position, they're not actually running. So you actually have to turn it off to activate the LED. So that's what that's doing. And here we call our set GPIO function in the other file that will actually turn the LED on. And these two lines, again, they don't really do much. They just get rid of the aliases. So pin number and pin val no longer refer to register 0 and 1. Like I said, this has been in the previous tutorials, and all it does is create a delay. We're just going to start off with this number and just enter a loop and take away 1 from it until it equals 0. So nothing too exciting there. And again, this is, like I said, very similar to this code that turns the LED on. You'll notice the only change is that we set pin val to 1. So that means we'll be saying, hey, turn that pin on, which again, counterintuitively, will turn the LED off. And here's just another delay. Then we get to this loop, or sorry, we get to this section, which tells the code to pop back up to the loop. Alright, so now, alright, so here's the GPIO file. I'll be doing the same thing here. You'll notice this is much more heavily commented. It was all just new stuff to me. So as I was learning it, I definitely needed to write a bunch of notes. So we'll get started. This is our first function. Now functions are, I kind of explained it in this blog post, but functions. Sorry about that. My roommates were getting a little rowdy, but like I was saying, functions are somewhat tricky in assembly because they're not actually built into the language like C++ or any other high-level language. They're gonna have functions. It was not built into there. So functions are really just kind of things you can trick the assembler into doing, um, and just kind of a way to organize our code. They're not actual constructs. So because there's no formalized way, or there was no formalized way to do them, there was something created called the application binary interface, which is just kind of agreement an agreement among coders in this particular language on how we're going to handle functions. And just I listed them, the requirements for the ABI in the post already, so I'm not going to go over them again here. But we're going to start off with this function right here, the get GPIO address. The first two lines here aren't actually part of the function. They just this is just the function name, and this is saying that this function is to be available in all files. So it's as if this was written in the same file as main, but we just put it in here for organizational purposes. This line right here, all it's doing is R0 is going to be our quote-unquote output. So we're setting the register R0 to the address of the GPIO controller, and that's all it does. This section, the section right here, we're going to, well, you can read the comment right here. Give the link register address to the program counter, i.e., move back to where we were before the function. The link register is kind of our proverbial trail of breadcrumbs. It brings us back to where we were before this function was called. Anyways, so move on to the next function right here, the set GPIO function. Sorry again. I believe I was just around here. So the first part of this function, we're just going to make sure that we were passed in proper values for the for the inputs, which are the pin number as well as the function code. So the pin number is going to be between 0 and 53, seeing as there are 54 pins total, and there are 8 functions total, so this will have to be between 0 and 7. So if either of those evaluate as this number being lower, or this number rather being higher, we're just gonna jump back to the where we were with the link register, because we don't want to execute the code if we're not actually talking about a real pin number or a real function. This line right here, we're gonna push rather the link register on top of the stack so we can get back to it later. Get back to this point specifically, this address. Because we're gonna call GPIO address, we need to, and we want to save the value right now that's in R0. We're gonna move it to R2. We then call GPIO address, and after this call, our current standing is R0 contains the GPIO controller address, which is all of this function does. R1 is going to contain the function code, as we set up here, and R2 will contain the pin number, which we moved over here. What this function is going to do, the function codes are stored in blocks of 10. So all this loop is going to do is determine for us which block our function code is in. And then this last bit of code will just finish it off, and after we execute this, we'll have the register set to the proper GPIO function. So we're actually ready to we've done all the setup work, and now we're actually ready to run the next function, the set GPIO function. So the first parts, they're just aliases again. We have the pin number and pin val set to R0 and R1. So this part again, we're just gonna check to make sure we still have valid pin numbers and function numbers. Make sure they're not higher than what they can be, namely 53. After that, I'm just going to talk about this section. Its overall purpose is to determine. The pins are grouped into 2 sets represented by 4 bytes, so 32. There's 32 each. This will determine which of those 2 sets the pin that we're talking about is in. This next section, which I found particularly tricky to understand, we need to calculate a number that a 32-bit number that has only one bit set to a 1, and that 1 bit is going to be in the position of our number within this 4-bit. set. So, for example, if we're talking about pin 16, which is the act LED that we're trying to turn on, we're gonna have just a 32-bit word with the only one being 16. And lastly, this just executes the code. This line is the most important, I'd say. We're gonna turn the pin. This is what actually will turn the pin off if the value is 0. So if it is equal to 0, we're going to make the set bit 40, which will corresponding to 0, turn the pin off. Otherwise, if it's not equal, we're going to set the make the set bit to 28, which will turn it on. These two just get rid of the aliases, and then we return. Just pop the address off the stack of where we were previously. So, thank you for watching.